Hey Grace, I'm going to go over some corrections from this Unit 17 test. It's possible that this video gets kind of long. Several of these questions are going to take quite a bit of explaining, so just make sure you're watching through the video, maybe even work out the problems as I'm working them out to kind of help it stick. So number one asks to solve by factoring. When you factor, there are a lot of things you have to take into consideration. I always start factoring by drawing two sets of parentheses. In the first part of each parenthesis we have to have factors of 5, and in the back part of each parenthesis we have to have factors of 4. The tricky part comes when you do some guessing and checking, because the outside and inside terms multiplied together and then added need to give you that middle term. So anytime I see a prime number, I always start with the prime number. 5's prime, 4 is not. So I'm going to start with 5. That's the number that's out in front of the variable, so we're going to do 5z and 1z, because 5 times 1 is 5. In the back we need factors of 4, so we have a couple options here. We can do 4 and 1, or we can do 2 and 2. And I'm going to go ahead and start with 4 and 1. When the back number is positive, your signs should be the same, and they're going to match the middle term. So this means they're both going to be negative. Now if I multiply the inside terms, negative 4 times 1z is negative 4z, and 5z times 1 is negative 5z, and when I add those together I get negative 9z, and that's not the middle term. I'm looking for a negative 21. So because I'm looking for a negative 21, I need to try again with some different factors. This is why it's important sometimes to put in that prime number first, because I don't have any other factors of 5 other than 5 and 1. So now I'm just going to mess with these factors in the back. 4 and 1 didn't work, so the first thing I'm going to do is just switch them and try 1 and 4. So this gives me negative 1z, this gives me negative 20z, and when I add those together, negative 1 plus negative 20 is negative 21z. That is in fact what I wanted to get in the middle, so I factored this correctly. Now I need to actually get the solutions by setting each of the equations equal to 0, each of the parentheses. So I'm going to get two answers, one from 5z minus 1 equals 0, and another one from z minus 4 equals 0. Recognize that 1z and z are the same thing. So here I'm going to add 1 to both sides. This is just a quick two-step equation, and I get 5z equals 1. Then I divide both sides by 5, and I get that z equals 1/5. On the other side, I'm just going to add 4 to both sides, and that's going to give me z equals 4. So your answers are 1/5 and 4. Number 3 is asking which of the quadratics has the narrowest graph. So the narrowest graph is going to come from the largest coefficient. The largest coefficient on the x squared term. So you can compare 1/8 to 2 to 3 to 1/3 and see that this 3 is the largest digit. Negatives and positives don't matter, because all the negative means is that it opens downwards like this. So again, the largest coefficient is going to be the narrowest graph. The opposite of that would be that the smallest coefficient would be the widest graph. So something really wide parabola that would graph like that. Number 4 asks to solve by graphing the related function. So if we graph this, you're going to need some graph paper, but I would just, first I would add 12 to both sides. So we get 3x squared if I add 12 and add 12. 3x squared equals 0. So if I were to graph this, you can kind of think of this function now as f of x equals 3x squared, or y equals 3x squared. So we can plug in some different x values. If you do that, plug in different x values, you'll find that the graph crosses the x-axis at 0. So it would look something like this. I'm not sure how the lesson explains how to graph, but typically you just make a table of values and start plugging in numbers. To me, it's a little easier to solve this one by factoring, but since it didn't ask you to do it that way, although it is multiple choice, so really with a multiple choice, as long as you get the correct answer, it doesn't matter how you get it. Okay, number 5 asks, it's a kind of a story problem here. Suppose you have 54 feet of fencing to enclose a rectangular dog pen. It gives you the area equation, and it asks what width gives you the maximum area. So what we want to do here is just factor this equation. So if we have x squared, negative x squared, I'll just write it the way they've written it. 27x minus x squared. If we factor this, we would take out an x, and we'd be left with 27 minus x. If we set each one of these equal to 0, we get x equals 0 for this part, and we also have 27 minus x equal to 0. If I solve this one for x, I could add x to the other side, and I get x equals 27. So then we're going to take half of 27, and that's 13.5. So if that's the width, we need to find out the length. So you're going to do 54, I've got a calculator here, minus 13.5 minus 13.5. That leaves me with 27 left over. So I need to divide that by 2. So again, it's 13.5 and 13.5. You're actually going to find out that anytime you have some fencing to enclose in an area, in order to maximize the area, you want it to be a square. Squares will maximize the area. So 13.5 times 13.5, because the length and the width end up being the same, is 182.3 feet. Number 6 wants you to solve by factoring, so every time I factor I always set up a set of parentheses. This time I don't have a coefficient in front of the z, so the z's just go in the front of each set of parentheses. The back number is negative here, so I need one of each sign. Because the 6 is negative, the sign should be opposite. And I need to get a negative 1 in the middle. So I'm going to do positive 2 and negative 3. Remember, the back two numbers are factors of 6. So when I add or multiply these together, I get 2z and negative 3z, and then adding those gives me negative 1z. So now I have it factored, and I need the solutions. So the solutions come from setting each set of parentheses equal to 0 and solving. So if I subtract 2 from both sides, I get z equals negative 2 for one answer. If I add 3 to both sides, I get z equals 3 for the second answer. Seven asks to solve using square roots. This is probably the simplest way to factor. So when you don't have the x term, so I'll write that here, you can solve by square roots when there's no x term, there will be an x squared term, but not an x term. So I'm going to rewrite the equation over here. First thing we need to do is get x squared by itself, so I'm going to add 15 to both sides. That gives me x squared equals 49. And then the opposite of squaring something is square rooting it. So the squared and the square root cancel each other out, and I'm left with x equals the square root of 49, which is the positive and negative 7. And that's read as plus or minus. So you may hear or see the plus or minus symbol like you do here in the answer, but it comes from square rooting 49. Number 8 asks how the graphs are different. So you'll notice in the equation the difference is the plus 4 that's back here and no plus 4 behind this one. And what you need to remember is that when there's a number added to the back behind the x squared term, it's going to shift things up and down. So up because it's positive. If it were, let's say, minus 4, then it would have shifted it down. So if we looked at a graph, and I'm just kind of imagining here, if this is what 7x squared looks like on a graph, then shifting up 4 units be the exact same graph, and obviously I can't draw the exact same graph again, but this would be the 7x squared plus 4 graph. Nine asks to write it in standard form and then factor. So standard form is ax squared, it's ax squared plus bx plus c equal to 0. So we got to get everything on the same side. I like a positive x squared, so I'm going to leave the 2x squared alone. And I'm going to add the x to the other side and subtract 28. I'm kind of doing this all in one step. I subtracted 28 from both sides and I added x. So you can see it's basically just changing the signs. So now we want to factor. And again, when it's multiple choice, you could actually just check the different answers to see which one gives you this problem back versus trying to sit here doing the guessing and checking. You can see that they use the factors 2 and 1 and 7 and 4 in all of these examples. So if it's 2x and 1x and 7 with 4, and I'll just show the example with the actual right answer. Again, the back number is negative, so we need one of each sign. This gives us negative 7x. This gives us positive 8x. I'm multiplying those together. And now when I add them, the inside and the outside term, that's the 1x that you're trying to get here. So it is in fact that fourth option, or this one right there. So the zero product property is just a fancy way of saying set each one of those equal to 0. So this is, it's factored, but it looks a little different because instead of 2 sets of parentheses, that first set of parentheses is actually replaced by just a variable. So there weren't enough terms, there weren't 3 terms originally to factor it. So you're going to set negative n equal to 0 and solve. Remember, this negative is just like having a negative 1. So if you divide by both sides by negative 1, you get n equals 0 still. And then you have 5n minus 4. And you're also going to set that equal to 0. So we add 4 to both sides, and we get 5n equals 4. Divide both sides by 5, and you'll see n equals 4/5. So you get 0 and 4/5. Okay, the next one asks to find the axis of symmetry, coordinates of the vertex of the graph. So we have y equals 4x squared plus 5x minus 1. So in order to find the vertex, we're going to use that little formula that hopefully they were giving you in the notes. So that formula for the axis of symmetry is x equals negative b over 2a. And remember that a is the number in front of x squared, b is in front of x, and c is in the back. So if I do negative b, that's negative 5 over 2 times a is 4. So negative 5 fourths, or excuse me, eighths, negative 5 eighths is your axis of symmetry. So that rules out this one, and it rules out this one. Now you have to take that axis of symmetry and plug it into the equation in order to get the y value of the vertex. So this is the axis of symmetry. It's also the x value of the vertex. Remember that the vertex of the parabola is this point here, either at the bottom if it opens upwards or at the top if it opens down. So now we're going to plug this back in, and this can get a little bit messy, so make sure you have a calculator. But if I plug negative 5/8 in, I'm going to plug it in here and here. So it's going to be 4 times negative 5/8 squared plus 5 times negative 5/8 minus 1. So first thing we're going to do is square the fraction. That's 4 times 25 over 64 plus, if I multiply, I get negative 25 over 8 minus 1. And multiplying here, I can actually cancel. If I put this over 1, now 4 goes into 64 16 times. So this becomes 25 over 16. And I'm going to go ahead and get a common denominator right now. So times 2, common denominator needs to be 16. So 16 on the bottom, that's going to give me negative 50 up top, minus 16 over 16, because that's what 1 would be. So 25 plus a negative 50 is a negative 25. Negative 25 minus 16 more, 35, 41. So this becomes negative 41 over 16. And it looks like it's this answer. 16 goes into 41 twice. That's 32 with 9 left over. So that's why it's that top answer. The next two ask you to solve using square roots. So for the first one, we want to solve for x squared by dividing both sides by 6. We get x squared equals 9. When you square root both sides, x equals plus or minus 3. On the next one, we want to add 14 to both sides. When we add 14 to negative 10, we get x squared equals 4. Square rooting both sides gives you x equals plus or minus 2. (16) asks which one has the narrowest graph. So again, the narrowest graph has the largest coefficient in front of the x squared, and you don't have to worry about positive or negative. So that's the 10. 10 is the biggest one there. Negative 10. Again, solve using square root. So the thing here with number 17 is you can't have you can't take the square root of a negative number. So instead of subtracting 16, I'm going to add the x squared to both sides. So I get 16 equals x squared, and you can write it the other way, x squared equals 16. But you square root both sides, and we get x equals plus or minus 4. So I think for on some of these you just didn't recognize that you get a positive answer and a negative answer, because remember that negative 4 times negative 4 is also 16. Okay, so the vertex of the graph comes from first finding the axis of symmetry and then plugging that value in to get the y. When there's no x term, the axis of symmetry is really easy to find. So we get x equals negative b over 2a. There's no b term here though, so the top is 0. So 0 over 2 times 1 is just 0. So my axis of symmetry is at x equals 0. It's also the x coordinate of the vertex. You find the y coordinate by plugging the 0 back in here. So 0 squared is 0. 0 plus 2 is 2. So that rules out these two. The question then is the vertex a minimum, which means does it open this way, or this would be a minimum, or is it a maximum, meaning it's the tallest point on the graph, and it would open that way. And that's told by is x squared positive or negative. So this is when x squared is negative, this is when x squared is positive. So you have a minimum at negative, or at 0, 2. That means it's the lowest point on the graph. 19 is similar to the one we did a little bit earlier. So we want to first find the axis of symmetry, negative b over 2a. So b is 4, so we want to do negative 4. A is 2, so over 2 times 2, that's negative 4 over 4, or negative 1. So that rules out this one and this one. And now we're going to take that negative 1 and plug it back into the equation where both x's are and solve. So 2 times negative 1 squared plus 4 times negative 1 minus 3. That's negative 1 squared is 1, 2 times 1 is 2, 4 times negative 1 is a negative 4 or minus 4, and then minus 3. So 2 minus 4, negative 2, negative 2 minus 3 is negative 5. There. Okay, so I know that that was kind of lengthy and this covers a whole lot of material and I went over it pretty quickly. It looks like you missed a lot of the square root ones, so make sure you understand how to solve an equation when it says to solve by using square roots. And then also maybe go back over the lesson with axis of symmetry and the vertex so that you know you're using that formula properly. If you have any questions, let me know, but as soon as you've watched this video, I will reset the test. And you also need to kind of pay attention to your pace, and I know that you've been struggling with this unit, so it's taking you a little longer, but you may have to double up on some lessons so that you're sure to get done by the end of the trimester.